Jason. Saying different application, but curious how to approach running cybersecurity for cloud applications. Where you have data you cannot pull and view due to privacy requirements, where the model is deployed, pushed out, instead of pulling the data to run to training. Okay. Oof. Sahar, can you help me out here? Sorry. So I'm going to repeat the question because I'm still trying to parse it. Okay. Cybersecurity in a cloud application setting. You have data you cannot pull and view due to privacy requirements. The model is deployed, I guess, on the cloud. And no, actually, I'm sorry, I can't.
So I cannot different application, but curious how to approach running cybersecurity for cloud applications where you have data you cannot pull or. Do we have a schema? So everybody can see the question, right? So the question is you cannot pull the data or view the data. The model is running and is in cloud. So it doesn't matter where it is practically. Like you have data somewhere that you cannot see and you cannot.
So you have model output, but you can't actually see what triggered.
The privacy. So Jason, do we have a schema of the data? So we have to have something to work around it, right? I answered something. It's if you have a distribution of fields, if you have a schema, we might make a model around it. Like, okay, we have field A, distribution look like that, information is it categorical or not, like those type of information we can make based on what is it, like supervised or even unsupervised, but the controls wouldn't be 100%. Like,
but you could use feature importance, right?
Yeah.
So, and then there's like row-wise, like.
Which
one is row-wise? Is that line? Is that
I think so.
row-wise?
I cannot know.
Yeah,
it's just like you have to work with whatever you have, or try to get the exemptions on the viewing data. That happens.
Yeah, sometimes it's just like, hey, I actually need permission to see this in order to
give you something.
Yeah, but yeah, feature importance and having the schema and saying like, okay, well, this is this type of value, this type of value. You can make some qualitative inferences as to maybe this is benign or this is malicious. Okay.
There are some words on differential privacy as well.
That's true. And fully homomorphic encryption.
Yeah.
So there are options.
There are options. Like I haven't been in this situation, but I know there are options on like in differential privacy or some sort of activity like that. There are solutions, but I haven't been in this situation.
That would be a really good workshop to give, by the way. Just saying. Differential privacy workshop. I would attend that.
Okay. Noted.
Okay, one other question. If the distribution of the sample log is highly important, does that mean detecting new threats would be very hard?
Is it based on what I said about the distribution, or based on your?
Based on what I was saying.
Okay.
So you're saying, yeah, it is hard, and you know, threats. You get this distributional drift over time, so you need to retrain your model constantly. But the main point is that if you have enough of a longitudinal view of what's normal, of this computer normally talks to this computer at this time, on this day, or these days, and you know, this server is normally sending things to these people, whatever it is, you start to build up, this is a profile of what's normal. Okay, everybody has a routine, whether you know it or not, but it's very easily profiled. You get up in the morning, you go on the train, you go and you stop off in your coffee place, you go into your meeting, you go to the same food court. Sorry, I'm going to start depressing people now. But there's a lot of routine that humans are building into their lives, and like, so that's
go
what.
Go to the gym, start painting, do some active.
Write your magnum opus. No. Okay, I just sit on the couch and watch Netflix.
I know. Me too, but.
But the point being, that you start to what you're trying to model here is normal behavior, not abnormal behavior. And that's, I think, where the strength is. If you're constantly trying to model abnormal behavior, you're always going to be playing a game of cat and mouse to a large degree. Because, you know, threat actors are always going to change up their operations. You then have to figure out what that is, and you have to keep on chasing after it. If you're modeling normal behavior, that's still a challenge because threat actors will want to obfuscate themselves and seem normal, there's a lot more data to model, but still, it's probably more preferable. Okay. All right.
Any other questions?
No more questions? Yeah.
Could you talk more about the for categorical variables, like whether to do uniform sampling? You said least probable or
right.
Most probable. Could you expand on that?
Okay, so say for example, again, it was fruit. The category is fruit, and you've got three fruits. You've got fruit. You've got banana. You've got orange, and you've got pomegranate.
Yeah.
So 60% of the time it's going to be orange. 30% of the time it's banana, and 10% of the time it's pomegranate. So that's the true distribution. Do you either just give each of those a 1 in 3 chance of being selected, or do you bias towards orange most, or do you bias towards pomegranate most? So what's going to end up happening, and I think you can play around with this today if we have time, but my gut instinct was more or less right, so yay. When it's the most probable distribution, you're more likely to challenge the model. If it's a least probable distribution, you're least likely to challenge the model. And if it's uniform, it kind of blends in between the two. There's a few different ways that I've noticed this. One is when generating the negative samples, I end up with a lot more rows that are colliding with the real data. So
yeah.
Than I do when I do uniform samples. So I think that's true. Yeah. So that's a problem. The other thing is that you just get slightly better performance in the end, but slightly more difficult training with the most probable data than you do with the uniform data.
Right.
So it's more work for the model, but it tends to perform better.
And also because you're doing that, you're as a whole with the negative sample and the benign data, you're maintaining the distribution of features.
Yes.
You're not
skewing it. Yeah, exactly. Yeah. Okay. So there was a couple of other. Was there another one there, or was that my imagination?
No, it was like.
Okay, that was.
You clear up the back one.
It's an announcement in the another.
Yeah. Okay. All right. So, if everybody wants, we can move on to the code.
Could you make that bigger?
Oh, sure. Yeah.
They can't see it. There's something else. You probably have to mirror the screens.
That's weird because I wasn't. I didn't pick a particular application. Oh, I think I know why. I'm still in full screen mode. No. I think it's just frozen again. I'll just stop screen sharing and then. Yeah.
I think it's because you're in presentation mode.
Close it then. Oh, yeah. Oh, I think I know why. Extend duplicates. Yeah. Okay.
Cool. Got it.
All right. So let's run through the code a little bit. So loading up our packages. Let's mint our drives. Hopefully this won't be a problem for anybody because I made the code correct this time. And these are our files. So we've got the red team file, compressed CSV. We've also got the auths file, which might not have text.gz, but it's also compressed. And then the rest is just the lecture materials. Quick and dirty function just to turn this counted number of seconds into days and into hours. So very simple. So this will give you return, get days will return a value between 0 and I think 58 or something like that. And hours is obviously going to return a value between 0 and 24. Okay? All right, so now we're going to import the data. I've named the features according to the labels in the data itself. So second is self-explanatory. It's the number of seconds since the logging has started. The source user domain, it's the domain that the source user who's doing this auth event is logged onto or coming from. The destination is, well, where is it going to? The domain for that. Source computer versus the destination computer. What type of, okay, this stuff I'm probably not so great on. Authentication type is like Karabos and things like that. I don't remember all of the values. And other things. Yeah, these are probably the most indicative though of anomalous behavior beyond this computer doesn't normally talk to this computer. And then success and failure, whether or not they actually managed to log on or if it was a failure. Okay. Then we're going to import the red team. So we import the data, sorry, and I'm also immediately calculating the day. All right. And we import the red team, and then we're going to just join it with the auths and create labels so that we know that okay, some of these events were red team events and the rest are just normal. So that's pretty simple.
You have a very small number of threads, right?
Stupidly small, 40. Okay, actually initially it's a little bit more, but I'm dropping duplicates here. Once I throw out the seconds and I only look at day of the week and hour, you get a lot of duplicates and I'm dropping those. So it makes it a little faster to train. And that means also that you lose some red team events. So you go from about 120 or something, 160 red team events to 40 red team events. So if you're running this, this is going to take a while because it is a big file, even though it's only 70 kilobytes, but that's compressed, or 70,000 kilobytes, but that's compressed. Was it 70,000 megabytes? Maybe 70,000 megabytes. I'm tired. Okay, so let's get a list of all the computers that we're actually going to use because we're going to sample this. So we're going to sample 8 computers out of all the ones that were involved. Initially, 12,500. I sampled it down to, I don't remember, it was around 20. And now I'm sampling it further down to 8 because that's still too much for this for today to run smoothly. You also have an issue that if you're generating your fake data, you're going to run out of RAM if there's too many rows. Okay, so we're going to convert from seconds to hours and also the day to the day of the week. And then we're going to get rid of the seconds because you don't want that in your training data. So again, if your test data is coming from the middle of that timeline, then it's going to seem very anomalous if you keep that as a feature going into the model because it's like, well, we never saw these points in time before. This second 5,321, that never existed before. So that would be flagged as anomalous. So you really want to make sure that whatever you're doing is going to help you generalize as best as possible. So we're going to get rid of that. And then the question that everybody's asking is how many red team events do we have versus how many actual events do we have? Once we do drop duplicates, this is going to be a lot faster. Okay, so we have 47 red team events and we have 370,000 real events, roughly. Happy hunting. Okay, so like I said, we're going to be cutting the middle out, and I think in that middle there's 40 or so events, right? So 6 red team events are going to be in the training data, but that's still pretty clean. That's not too bad. Okay, so this is just to, there's probably neater code for this, but this is just to turn the values into numbers. So anything that's whatever category it is, if it says apple, it's now 3. If it says orange, it's now 4. We're just numerically encoding all the categorical values so that it's easy for XGBoost to ingest that. Okay.
Don't we need to convert it to one-hot coding, or
No.
Can you repeat the question?
So, don't you need to convert to one-hot coding? Yeah, everybody always talks about one-hot coding like there's never a cardinality above 100. As soon as you get into very high cardinal categorical features, the last thing you want to do is one-hot coding, because you're just going to get this infinitely horizontal, data. You can maybe do another encoding, like binary encoding, if you want. I haven't had much joy with it. What I really love about XGBoost is you can just put this in, and it works. It actually learns, okay, this category, when it's above this value, and when this category is below this value, and then from a bunch of different features, it can create a rule. They literally just saying, do I split on this number or not, or in this product of numbers? So you can actually, it works quite well. It's a really good question, and this was something that was a debate in my workplace many years ago, and I think I won. But I mean, XGBoost seems to handle it just fine. So, and it's so much easier. Yeah. It definitely helps. Yeah, but I think it's a very robust tree model. Like more than, other than a decision tree, it's not going to do a good job. Yeah. Yeah, but if you've got multiple levels. Yeah, you're right. And like, this probably is a lot more rigor you could do, but you can be quick and dirty if you want, and it seems to work fine. But if you want to be more rigorous in there, please do. Another issue then that I actually have with one-hot encoding is, or if you vectorize something, is that you end up dropping any use of explainability. So XGBoost can tell you, or feature importance. So XGBoost can tell you this feature is really important. But if you split your feature now into 6 features, then it's just going to say, well, this component of this feature is important. What does that really mean? You're starting to lose interpretability there. So it can be a problem.
One of our team members use it when trying to detect DGA detection.
One-hot encoding?
Yeah, like.
If the cardinality isn't too high, then it's
Yeah,
fine.
Yeah, mostly because like the bolts are not.
Yeah.
Changing.
Yeah, no, like it's a perfectly valid approach. It's just it doesn't scale. Is the only issue.
That's the
Yeah.
only issue.
What did you do? Sorry, I didn't hear.
Generation.
Domain generation, DPA passage. You should-
Algorithm?
Algorithm, probably. So it's a technique, attack technique that when a malware sits in your computer and try to connect to a website outside the website, most of the domains are known, right? Like if it's a malicious website, you cannot keep one address and like always malwares connect to that. That like it's easy to protect. Like somebody block them and like it's protect. So one technique that attackers use is they use some sort of algorithm, and the malware has that code that generates algorithm. They have that code that generates algorithm and just keep generating new web pages. So the malware tries to connect to those random web pages. And some of them are really small, like they use dictionary obviously, and they make domains that look or sounds very legit, right? But they are just bad websites. So it's hard to detect them.
So yeah, URLs is actually a really good example of where feature engineering can come in handy.
Oh, yeah.
Like if you're looking at, is this a malicious URL or not? just doing something so simple as character count. If this is a really long URL, oftentimes it's because they've got some nasty thing embedded somewhere in that link. So feature engineering, coming up with ways of saying like, well, how many characters are in there? How many are ASCII? How many are like from some other encoding? Stuff like that. You can come up with stats that are very helpful.